Dear Math Shop, why don't you give away prizes like other game shows? I'd volunteer to be a guest if you'd... Dream on! Okay, what's this one? Dear Math Shop, I watch your show regularly and think it's great. This is more like it. Think it's great. I especially like the episode where Trask was waiting in Crystal's apartment and got caught by Ripper. When is Doobie going to have her operation? Are Teak and Kendall going to have a surrogate baby for Rachel and River? Ah, someone without a life. Maybe this one's better. Dear Math Shop, can you help? I suffer from terrible math anxiety. Okay, this is more like it. The worst is these long, complicated x squared plus 4xy things. Sometimes I have nightmares and that they're like snakes crawling through the grass, but I can't even tell which way they're crawling because they don't have eyes. What am I going to do? Signed in need of a lifeline. Oh, that's terrible.
What's terrible?
Oh, this letter from one of our viewers.
Let's
look.
see. Nightmares,
Yeah.
snakes, don't have eyes. Oh, more math anxiety. That's terrible. But what does this mean about the long, complicated things like snakes?
Well, I suppose it means polynomials. I think that's something that we should address in the show today, Kanwal.
Well, we're talking about polynomials anyway.
Oh, good, good. But let's deal specifically with people's anxieties. I mean, people shouldn't be afraid of a few numbers and letters, you know.
Fine, I agree 100%.
Oh, great. Hi, and welcome to the Math Shop, where mathematics is a part of everyday life, and the skies are not cloudy all day. I'm Christine, and this is my math partner, Kanwal. And this bunch of chips and wire over here is Euclid, my homemade computer.
Today, we're going to talk about polynomials.
Specifically, we're going to show you how to simplify polynomials, how to add like terms, how to multiply, and how to divide polynomials.
But first, we're going to begin with a little refresher on the language of math.
Right. We know that people get anxious about math because they're learning a whole new language. And if you don't understand the language, how are you going to understand the concepts?
So let's look at this algebraic expression. 2x to the third power plus x squared. And make sure you know what all the component parts are called. Starting at the left, the first thing we find is the number 2. This is called a coefficient. It means 2 times whatever follows. In this case, a letter and a superscripted number. The x is a variable or an unknown in the expression. We could have used any letter to represent the unknown. The superscripted 3 is an exponent or a power, which in this case means x times x times x. And you know that x to the power of 3 is often read as x cubed. The plus sign is called an operation. Next is another variable, x, and another exponent, 2. X to the power 2, or x squared. This expression has 2 parts. Each part, which is separated by an addition sign or a subtraction sign, is called a term. For example, this 2x cubed is a term, and so is x squared.
Understanding what terms are and feeling comfortable with the language of math is important to understanding polynomials. A polynomial is any mathematical expression composed of one or more terms. A monomial is an expression with only one term. Expressions with 2 terms are called binomials. Expressions with 3 terms are called trinomials. Euclid, some examples of each, please. And remember that terms are separated by a plus or a minus sign. For example, even though there's a 4, an x, and a 2 in 4x squared, it's just one term. But all of these expressions are polynomials. A polynomial can be a monomial or a combination of sums or differences of monomials.
Sometimes you may be faced with polynomials that are like my storage room. They have a little bit of everything in them. And just like organizing a closet, one basic approach to simplifying polynomials is to combine like terms. In the closet, you put the tools together, and the skis together, and the toys together. In the polynomial, you put all the like terms together. Like terms have the same variable or variables and exponents. For example, these are all like terms. 2 x squared y, negative 3 x squared y, y, x squared, and x squared y. The first two are easy to understand. Both contain x squared y. In the last two examples, the order has been reversed. Y x squared y. But in multiplication, order doesn't matter. 2 times 3 is the same as 3 times 2. Now, unlike terms may have different variables and exponents. For example, the following are not like terms. 2 x squared y, 3 xy, negative x y squared, 2x. Now, if you notice the terms, they either have different variables or different variable exponent combinations. So they are not like terms.
Now the question is, when you find like terms, how do you combine them? It really means you add their coefficients. Let's look at a polynomial with some like terms, identify them, and then add them. Euclid, a polynomial, if you don't mind. This is a long expression, a little like the snake our viewer dreamed about. But if I look closely, I can see how to make it shorter. These are like terms, x squared and x squared. And these are like terms, xy and xy. And these are like terms, y squared and y squared. If I combine the x squared terms, remember I add the coefficients 4 and negative 6, the result is negative 2x squared. If I combine the xy terms, it means adding the two coefficients, negative 6 and 7. The result is 1xy, or just xy. Lastly, I combine the y squared terms, which means adding 5 and negative 2. The result is 3y squared. Now, when we compare the original with the simplified expression, we find that combining like terms has made it much easier to understand. Now let's try another one. In this case, I see two x terms and two y terms that can be combined. But before I start adding them, I need to deal with the parentheses. The subtraction sign means I need to subtract each term within the parentheses. So this is what we have. This, which is the same as this. And when I combine the terms, I find that 4x minus 2x is 2x. And 2y plus 5y is 7y. So, by combining like terms, you get a simpler expression. 2x plus 7y.
When you encounter a problem in your textbook, quite often it'll ask you to evaluate the polynomial, given certain values. Whenever you do this, always check to see if the polynomial can be simplified first by combining like terms, before you substitute values into the expression. But now, let's try a problem involving polynomials. First, there is another language lesson. You may call this a pop can, but in mathematics, it can be also called a right circular cylinder. Now, suppose you were asked to find the surface area of your pop can. Remember, the surface area of a cylinder is given by the following polynomial. 2 pi r squared plus 2 pi r h, where r is the radius and h is the height. We did a similar problem in an earlier show. Euclid? Maybe you didn't know when we worked on this that you were already using polynomials. So, to find the area, I'll substitute the known values into the polynomial. Our 355 milliliter can has a height of 12.5 centimeters and a diameter of 7.4 centimeters. So my height, h, is 12.5 centimeters. The diameter D is 7.4 centimeters. So half of that would be the radius, so R is 3.7 centimeters. Now, our problem is evaluate the polynomial for h equals 12.5 and r equals 3.7 to find the surface area of the can. Now, we'll use pi to be 3.14. This shouldn't be too difficult. After all, we've solved similar problems before. First, I look to see if there are like terms to combine, but there are none. That means I can substitute values into the polynomial right away. 2 times 3.14 times 3.7 squared plus 2 times 3.14 times 3.7 times 12.5. Now, I multiply each expression and I get 85.97, trust me, plus 290.45. When I add them, I get 376.42 centimeters squared. So, the surface area of the can is 376.42 square centimeters.
Okay, when you're studying, one way to reduce math anxiety and keep you sharp is by taking an exercise break. But there are lots of other techniques you can use. We asked some people what they would recommend to someone who just can't cope with mathematics. Euclid, roll clip 1.
Trouble with math? Get organized. Prepare your study area. Lay out your tools. If you're a night person, work at night. If you're a morning person, work in the morning. Main thing, make sure you allow enough time.
Sometimes you just have to get away from it. Also, small children and studying do not mix. Get yourself your own study space.
I find that if I have one big problem, if I break it down into smaller problems, it's much more manageable, and with a positive attitude, I can handle it.
Don't work too long without success. Take a break, reward yourself. I like to get out in my garden.
If you need silence, go where it's quiet.
Try a relaxation technique like exercise. Try and keep to a schedule. Don't get behind.
Thanks, Euclid. I needed that. So remember, math doesn't have to give you nightmares, even when you're dealing with polynomials.
Our next step is to multiply polynomials. To do this, you can use the distributive law. For example, look at this expression. It is a monomial x times a binomial 2x plus 3. Multiplying the expression means multiplying each of the terms within the bracket by the term outside, like this. X times 2x gives 2x squared, and x times 3 gives 3x. So the result is 2x squared plus 3x. Let's look at another example. 3y squared times 2x plus 4y minus 3. Now, remember, according to the distributive law, every term within the parentheses must be multiplied by the term outside. So we could rewrite this expression like this. 3y squared times 2x plus 3y squared times 4y minus 3y squared times 3. Now, when I complete the multiplication, I get the following. 3 times 2 gives me 6x y squared plus 3 times 4, 12 y cubed minus 3 times 3, 9 y squared. So let me show you another way.
Oh, God, Kanwal.
Is this another exercise break?
Not really. Don't you know what this is?
Well, it's a sword.
No, it's not a sword. It's a foil. A fencing foil. Which means we're going to take a look at another method of multiplication. The foil method. Euclid, prepare to cross binomials. The FOIL method is used to multiply two binomials, an important point to remember, and it's called that because the letters F, O, I, L stand for the order in which you multiply the terms. Let me explain, and then I'll do an example. F for first terms times first terms. O for outside terms times outside terms. I for inside terms times inside terms. And L for last terms times last terms. Now the example. If we have two binomials, x plus 1 times 2x plus 3, the method gives us these results. We start with the first terms and get 2x squared. Outside terms give us 3x. Inside terms give us 2x. And the last terms give us 3. When I put them all together, I see that there are some like terms. When I combine them to simplify, I get this. 2x squared plus 5x plus 3.
But now, what do you do if you've got 3 polynomials to multiply? Here's an example with 2 binomials and 1 trinomial. 3a plus 2b multiplied by 3a minus 2b multiplied by 4a plus 5b minus 1. I'll use FOIL on the binomials. And then use the distributive law to multiply the result of the first calculation and the trinomial. Using FOIL on the 2 binomials gives me the following. First term times the first term equals 9a squared. Outside terms, 3a times minus 2b gives me minus 6ab. Inside terms, 2b times 3a gives me plus 6ab. And the last terms, 2b times minus 2b gives me minus 4b squared. Now, I inspect the result and see if there are any like terms. There's one here and here. I combine them and they cancel out. And I'm left with 9a squared minus 4b squared. Now, I can use the distributive law to multiply the trinomial, 4a plus 5b minus 1, with the 2 binomial result, which is 9a squared minus 4b squared. But let's do that on Euclid. 9a squared times 4a equals 36a cubed. 9a squared times 5b equals 45a squared b. 9a squared times negative 1 equals negative 9a squared. Negative 4b squared times 4a equals negative 16ab squared. Yes, I know, Euclid. It's all one line. But can you put it on the line underneath just for now so we can see it? Negative 4b squared times 5b equals negative 20b cubed. And negative 4b squared times negative 1 equals 4b squared. This is our result. Of course, I check for like terms. Do you see any? Our terms are a cubed, a squared b, a squared, ab squared, b cubed, and b squared. No, this time there are no like terms, so this is our final answer.
Your math shop. Okay, graphs. Oh, math, volume and surface area. Your math. Fan letter for Kanwal. Oh, that's number line. Hi, I'm trying to divide these letters into topics to get an idea of what gives our clients the most problems. One thing I do know is that of the 4 basic operations, addition, subtraction, multiplication, and division, a lot of people have the most trouble with division. And as for division of polynomials, well, some people think it just can't be done. But we've shown you how to multiply polynomials, and division is just a reversal of the process. Today, we're going to consider 3 cases of divisions: a binomial divided by a monomial, a trinomial divided by a binomial, and hang in there, a trinomial with a missing term divided by a binomial. Got that? Relax.
Let's start with a binomial divided by a monomial. But let's do a simple numerical example first. 6 plus 9 divided by 3. In this case, I divide the monomial 3 into each of the terms in the binomial 6 and 9. So this is the same as 6 over 3 plus 9 over 3, which equals 2 plus 3, which equals 5. Here's an algebraic example of a binomial divided by a monomial. 2x cubed plus 6x squared y divided by 2x. Again, you divide the monomial here on the bottom into each of the terms in the binomial above, like this. 2x cubed over 2x plus 6x squared y divided by 2x. And remember that 2x is the same as 2x to the power 1. When you divide terms with exponents, you subtract the exponents. Completing the division, I get x squared plus 3xy. Now, if you have a trinomial divided by a binomial, you have to use long division. Let me show you this example. X squared plus 6x plus 8 divided by x plus 2. X squared plus 6x plus 8 divided by x plus 2. Now, I look at the first term, x squared. Will x go into that? Yes, x times. So, x times x equals x squared. X times 2 equals 2x. Now, I subtract. X squared minus x is 0. 6x minus 2x is 4x. And I bring down the plus 8. Does x go into 4x? Yes, 4 times. So I put a plus 4. 4 times x is 4x. 4 times 2 is 8. Now I subtract. 4x minus 4x is 0. 8 minus 8 is 0. So the answer is x plus 4. Now, there is one other example I would like to show you, and that is long division of a trinomial with terms that are out of order or with missing terms. First, though, I'll explain what I mean by terms out of order and missing terms. Look at this example. 9x squared plus 6x cubed minus 5 divided by x squared minus 2x. The first term in the trinomial is 9x squared. The second term is 6x cubed. But when using long division, it's important that the terms descend in power from left to right. For example, x to the 4th power, x cubed, x squared, and so on. So in a case like this, you can just rearrange the trinomial so that the terms are in descending order. Let me change these two around. So I get 6x cubed plus 9x squared. If you look at the trinomial again, you'll notice that there is a missing term. There is an x to the third power and x to the second power, but no x term between x squared and the units. Again, you need this x term for long division to complete the series of descending powers, so you fill it in using 0 as its coefficient, plus 0x minus 5. And now, with the expression in descending order, complete with missing terms, I can perform long division. X squared goes into 6x cubed 6x times. So I multiply 6x times x squared is 6x cubed. 6x times negative 2x is minus 12x squared. I subtract. Now, remember, it's important to note that subtracting this changes the signs. Minus, plus. In other words, the negative 12x has become positive 12x, giving me a result of 0x cubed and 21x squared. Be careful. This is where a lot of people make mistakes. Okay, let's continue. I end up with 21x squared, and then I bring down the 0x, and x squared goes into 21x squared 21 times, so I write a plus 21. Now I multiply. 21 times x squared gives me 21x squared. 21 times minus 2x gives me minus 42x. Once again I subtract, and remember the signs change, minus, plus. The 21x squared cancels out. 0x plus 42x equals 42x. Bring down the minus 5. Now, x squared does not go into 42x. So, this is my remainder. And here's how you would write the final result. The quotient, 6x plus 21, plus the remainder, 42x minus 5, over the divisor, x squared minus 2x. Now, note that the remainder must be expressed over the divisor, because that portion of the division problem won't go any further.
And there's another thing that won't go any further, Kanwal.
What's that?
This show. We're out of time.
Oh, I guess we'll have to say goodbye.
Goodbye, and join us next time on Math Shop, where mathematics is more than just a living. It's a way of life. And remember, don't let the math blues get you down. You can win. You
really like that thing, don't you?
Of course. Demonstrates my rapier-like wit. I'll get it. Hello, Math Shop. Christine speaking. Oh, you saw it. Okay. He was in no danger at all. No Kanwals were injured during this show.